In part A, we're asked to find the centre of mass of the lamina, which is a rectangle with an isosceles triangle taken out of it. The best thing to do is to set up a little table of information to help us solve this. And because it's a lamina, we're going to be looking at areas first of all. So what we have with this lamina is a rectangle. Take away an isosceles triangle is equal to the lamina itself that we're looking for. Well, the area of the rectangle is 6 by 5, 6 times 5, which is 30 centimeters squared. The triangle has a base of 2 and a height, perpendicular height of 3. So half base times height is going to give us 3 centimeters squared. So the overall area of the lamina is 27. Let's look at finding the centre of masses of each individual parts of this lamina. So if we start with the rectangle, we can see that there's a base of 5, so the x distance would be 2.5, it has a height of 6, so halfway up would be 3. The triangle a little bit more tricky, but not too difficult. To get to the centre of the base of the isosceles triangle, we need to travel a distance of 2 to the edge, then a further 1 to get to the line of symmetry there, as indicated on the diagram. So the x distance travelled would be 3. And then obviously from AB, the y distance would be 1 to get to the base, plus another third. It's a third up for the centre of mass of an isosceles. So that would be a third of 3, which is 1, so that distance would be 2. And these would give you a respective x bar and y bar. So if we set up two moment equations, we can see for x bar we're going to have 30 times 2.5 minus 3 times 3 is equal to 27 x bar, and 30 times 3 minus 3 times 2 is equal to 27 y bar. So obviously if we just divide through those by 27, we'll get a value for x bar, which in this case x bar is equal to 2 4/9, and y bar is equal to 3 1/9 centimeters.